Algebra 2, today we're going to graph systems of linear equations. So a system of a linear equation is just simply two or more linear equations. It's going to be on the same coordinate plane. A solution to a system is an ordered pair, which is always xy, that makes all the equations true. As it turns out, there's going to be three different scenarios. So one of them is that you will have lines that cross, and the solution is the point where the lines cross. And so if they do cross, this is what one solution looks like. It could be that the lines are parallel, and so if the solution is where the lines cross and parallel lines never cross, there is no solution here. And then sometimes you will have like two lines that sit right on top of each other, and so all the points agree, and this is IMS. This is infinitely many solutions. So we will have three different scenarios. Lines cross, you get one solution. Lines are parallel, no solution. Lines sit on top of each other, infinitely many solutions. All right, so let's graph these. Step number one. You're going to plot the y-intercept. So in general, I like them in the form y equals mx plus b. Remember, your b is your y-intercept, and then the m is the slope of the line. Step number two, you're going to use slope to plot more points. We're talking rise over run. All right, let's do this first. So equation number one, x plus 2. So 2 is my y-intercept, so I'm going to start up here at 2 on the y-axis. There's an implied 1 in front of there, over 1. So I'm going to go up 1, right 1 a couple of times. And then I'm going to take my straight edge, and there is the graph for my first line. Let's see. So step number 3 is repeat for the second line. So I have y equals 3x minus 2. So your y-intercept is down here at -2. Slope is a fraction, so you can always put a number, you can put it over 1. So from this y-intercept starting point, I'm going to count up 3 and right 1. It's right there. 1, 2, 3, 1. If you ever run out of room, you can always go down and left. So down 3, left 1, because that would continue your pattern that you have. Take a straight edge, connect the dots. So you always want to extend your line through the entire coordinate plane. And step number 4, write your solution as an ordered pair xy. So right there, that's where the lines cross. So here's my solution. So if I go over 2 and up 4, That is the solution to the system of equations. That is the one and only unique point that will make both of them true. So neither of these on number 2 are in slope-intercept form. So I'm going to first start by solving for y. So I would subtract x from both sides. So y equals negative x plus 3. And then we'll do the next one. Negative 2x plus y equals negative 6. Add 2x to both sides. And y equals 2x minus 6. So negative x plus 3. So the 3 is my y-intercept, so I'm going to start right there at 3 on the y-axis. Your slope is negative x, so there's an implied 1 there, over 1. You've got to remember that a negative slope should end up looking like this, going downhill. So from the starting point, I'd go down 1, right 1 a few times. Take your straight edge, connect the dots. Number 2. This is 2x minus 6, so there's my y-intercept. There's my slope. I have a positive slope, so that one should be going uphill after you graph it. Up 2, right 1 a few times. There we go, it's going to cross right there. So my solution is that point right there, which is at 3, 0. On this one, it looks like we just have to solve for y. 2x minus y equals negative 1, and 5x plus 2y equals negative 16. So if I subtract 2x from both sides, get negative y equals negative 2x minus 1. I'm going to divide every single term by negative 1. Negative divided by negative is positive. Positive, so that is my first line I'm going to graph. Subtract the 5x over. You get 2y equals negative 5x minus 16. Divide every single term by 2. And y equals negative 5 halves x minus 8. So this first line, I'm going to start the y-intercept at 1. I'm going to go up 2 and over 1 a couple of times. Take your straight edge, connect the dots. On the next one, I'm going to start down here at negative 8. So I put the negative on the 5. I don't have room to go down 5 and right 2, but you could always move it. You can move the negative to wherever you need it to be, as long as you only use it once. So that means I'm going to go up 5 and left 2. 1, 2, 3, 4, 5, 1, 2. There it is. 1, 2, 3, 4, 5, 1, 2. And I'm sure you'll agree with me that this is the downside of graphing, is that if your ruler gets a little bit off, it's a little bit challenging. But my solution is right here at negative 2, negative 3. So when you do try these problems, you should have negative 2x plus 3y equals 9. So if I want to solve for y, I added 2x to both sides. get 3y equals 2x plus 9. Divide every single term by 3, and y equals 2/3 x plus 3. So there's my y-intercept at 3. Go up 2 and write 3 a couple times. And sketch your graph. And then for the other one, we have 6y minus 4x equals negative 12. So I added 4x to both sides. 6y equals 4x minus 12. Divide all three terms by 6. So y equals 4/6 x minus 2. 4/6, I recognize that I can divide the top and bottom each by 2. And so let's get in the habit of reducing all of our fractions first. So y equals 2/3 x minus 2. So plot your y-intercept down at negative 2, go up 2 and write 3 a couple of times. And you get two lines that look like this. So it looks like they're not going to cross, and it looks like that they are parallel. And they are parallel, and I can tell they are because the slope of my lines are the same. So they are parallel because they have the same slope. If they have the same slope and they are parallel, there will be no solution to the system of equations because solutions happens where lines cross and parallel lines don't cross. Next one. So the first one, 1/2 x plus 1, so we can start right in on that first one. Y-intercept at 1, go up 1 and write 2 a couple times. And connect the dots. The bottom line, you have to solve for y, so I would add x to both sides. So 2y equals x plus 2. Divide every single term by 2. There's an invisible 1 in front of that, so x over 2 is the same thing as 1/2 x, and then 2 divided by 2 equals 1. Wait, that's the same line that I just graphed. So this is line 1, and this is line 2, which is the exact same line. So when you have the same line, when you solve them, we call this, I usually abbreviate to IMS, it stands for infinitely many solutions. And then let's go ahead and do the word problem while we're here. All right, so we're going to rent some scooters. Sam charges $20 fee. So this is a flat fee. Anytime that it's just a plain old fee, that is always your y-intercept. And it says plus $5 per hour. We're looking for per means multiply. So every hour I'm going to pay another $5. Wherever you see per, that is always going to be the slope of the line. So the flat fee is generally your y-intercept, and the per is the slope of the line. Write a system of equations. So system number 1 is Sam's cost. So y is going to be the total cost. So my total cost is $5 per hour plus a $20 fee. So my first line is y equals 5x plus 20. And so your x is the number of hours that you end up renting the scooter. And then the other one is Rosie's cost. So her cost is a $10 fee. So that's my y-intercept, the $10 fee, plus $10 per hour. And that 10 is my slope. All right, so we have to label it all. So x was the number of hours. So when I label it, x is going to be the number of hours that I rent it for. And we should be able to generally just count up by 1 on the x-axis. However, the y is going to be your total cost. And so we're going to have to count up by something different. And I think $10, if I count by tens, that should work. All right, so Sam, so this has a y-intercept of 20, and then it has a slope of 5 over 1. So you have to pay attention. So we can't go up 5 units and over 1 because my x and my y-axis are counting by different units of measure. So if I want to go up 5 and over 1, so this axis is counting up by 10. So when I go up 5, I'm really just going up half the distance. So there's up 5 and right 1. Up 5, right 1. Up 5, right 1. All right, so I have a couple of points plotted. So then I would just take my straight edge, connect the dots, and so that one is Sam's cost. And then my second line is going to be for Rosie's cost. That has a y-intercept of 10, and that has a slope of 10 over 1. So this one's easier. So when I go up 10, it just looks like I'm going up 1 space, up 1 and over 1. So because my y-axis is counting by tens. I generally try to make enough points until I see where my lines are going to intersect. All right, so that is where the lines cross. That's the solution to the system of equations. All right, so I can see that my solution is going to be at 2, 30. The 2 was the hours, so at 2 hours, and then the y is your dollar amount. It's going to cost me $30. When does it make more sense to rent from Rosie? All right, so at 1 hour, she's the blue line. She was only $20, but Sam was $25. At 2 hours, they were the same. At 3 hours, Rosie's this top line. So she's 40 now, but Sam is only 35. So it looks like under 2 hours, that's when I rent from Rosie. That's when her cost is less. When am I going to rent from Sam? So his line is under hers, and so from 2 hours on, anytime you want to rent, he's going to be less expensive. So more than 2 hours. Is there ever a time when it doesn't matter? Yeah, at exactly 2 hours. Because they're both $30, and that's where the lines cross. So that's the point where their cost is the same. If you were renting a scooter from Rosie, how much would you pay if you wanted to rent for 7 hours? All right, so Rosie's cost is y equals 10x plus 10. If you are renting for 7 hours, so that means x equals 7 because x was the number of hours, because that's what the label on the graph says. So I have 10 times 7 plus 10. So I have 70 plus 10, and that would cost $80.